Hello again, and welcome back to the programming bootcamp. I don't know how many episode is already, and maybe we're going to cut it up anyway. But anyway, welcome back. My name is Gabor Sabo. Nora Torasova is with me, as earlier, and we are going back to the slides, to the screen sharing, and to the slides, and then sorry, I just have to move the upper window as well. So this is the main slide, and we stopped the previous video with the exercises that we had that were on the command line, that we're using the command line. And so let's just quickly look at the solutions. But I mentioned that the main body of the program is going to be the same. The difference is that now instead of asking the user with the input function to give us some input, we check if the command line has exactly the right amount of variables, of parameters, and not then we give some explanation. So it's now this time it's a little bit different than what I used it earlier, where I said usage. This one I just say needs 2 arguments width and length. And then we take the value, so assuming that we actually have the three parts. So the first one is the name of the program, and then the second and the third are the width and the length, and then we use them, converting them to integer, or we can use it to floating point, whatever you like. Again, here too, we don't check whether the conversion works. So if it doesn't, then it will just blow up. At this point, we don't care about that much. And that's it. The rest is the same. And the calculator, okay, so the calculator, wait a second. Sorry, right. So this is the calculator example. And this is again quite similar to what we had earlier, except that we check the number of parameters. Here it was slightly different. I checked if it's less than 4, maybe it's incorrect. Right, so it's not really correct, because if we give too many, that's also not good, I guess. So then people won't understand why you didn't do anything with the rest of the parameters that they gave you, and that's can give you confusion. And anyway, so we get the parameters from the user. So the zeros element is the name of the program. The first element, or index 1, is the parameter A. And then, so this time we are expecting the user to type in 2, and then plus, and then 3, as if it was a regular math operation. So instead of 2 space 3 space plus, you type in the number, operator, number. And so the first number, then the second number, which is number third place, and then the operator is from the second place. And then the rest of the code is the same. And then previously I mentioned that some people think that you could just, you have this 2 plus 3 already somewhere. Why can't you just say, okay, just compute it? And that's the next slide. So here we are using a new function that we haven't seen called eval. So eval, and what we do is it might look a little bit strange. So we concatenate the strings. So we get from the user 3 strings now. We don't convert them to numbers at this point. We combine them, we concatenate them using the plus operator. This regardless of what is in the OP, into one string, and then we run this eval thing. Again, this is lowercase l. We run this eval thing and tell basically Python, take it as if this was a new Python code, and run it. And the result will get back to this variable that I called res, and then we print it out. So if we run this program like this and give it 2, 3, and the plus operator, sorry, this is a bad output. That's what wrong thing what is here. So calculator eval. Let me run it. Python calculator eval. Why does it ask? Oh, sorry. Okay, totally messed up. So this solution, now I'm looking at, let's look at the solution. So in this solution, actually we ask the user. So it's in the wrong, even the wrong place, the slide, because this solution should be in the first part of the, where we were asking the user for input, and therefore that's actually the right output. So sorry for the mess up. So in this solution, we are asking the user for input from the standard input instead of the argv, as in the second section of the exercise. But then we are using the eval. So let me actually show you. So now it's asking me, I type in number 2 and then number 3, and then let's say the star operator. Okay, so, and it first it prints out the actually string that I built together from the 2 and the star and the 3, and then it actually calculates and the result is correct. Okay, so it looks like, I mean, it's much shorter solution than all those ifs, right? And yes, so this is okay, but this is a super insecure thing, because what Python does is actually takes whatever I typed in here, the 3 things, combines them together, and then executes it as if it was Python code. So just as I mentioned with the input of Python 2, that can be dangerous, this too, if the user manages to type in some code that would remove a file from your file system, then you just blindly execute it. You don't check it ever. And right, in this such small program, you might say, okay, it's only used for math anyway, and it's used by people who are already on the computer, so I don't have to care because they would be able to do it anyway. But in the general concept is to try to write your program in a way that even if someone sends you some insecure data, it won't cause harm to your computer system. So, I mean, you start out with a program like this and then start building more and more things. And at the beginning, really put people sitting at your computer and doing this some stuff. But at one point, someone will tell, okay, ask some other person, just send me over a file and I will run this on it. And then suddenly you get input from people you can't really trust because those come from other places. And at one point you might hook this up, or a large application that this is part of it. You hook it up to the internet, and then suddenly all the, I don't know, 7 or 8 billion people can actually send you commands to this thing. So it's much better to avoid any of these issues, and especially eval. The eval command is really not recommended in, let's say, the first 5 years of your programming life. Okay, so why I'm showing this? Well, first of all, because people ask, okay, how could you do this? And then I wanted to show that it's actually possible. And the second thing, because this gives me the opportunity to talk about something that I wanted to talk anyway. And this is the question about programming, about compilation versus interpretation. When we started, I mentioned that for programming Python, you need an editor and a compiler or interpreter. And I wasn't really clear about that. So now let's talk about these two words and what is the meaning of these two things. So there are 10 languages that are what we call compiled languages. For example, C and C++, and lots of other languages. And there are other languages that are interpreted languages. For example, languages like the shell that the commands that we gave to the computer, it's a language, but this is interpreted immediately every command. And BASIC and so a lot of other languages. So a compiled language would work this way. You have an editor, you write your code in that language, then you take the compiler, you compile your program into something that can be executed on the machine. Then you can take this part and give it to anyone, and they can write on their computer without the source code and without the compiler. without anything else, just your program. Okay, and it can be really, really useful because you can easily distribute programs like this. That's one of the main advantage of it. The other version, the interpreters, if a program is interpreted, then the way you write it is then you write your code in editor, then you ask the interpreter to run it. You don't have this first compile and then separately run. You just run it immediately. And the interpreter reads in the first line usually and executes it. And then reads the next one and executes that. So it goes step by step. So you might have a really low-level syntax error on line 17, and you encounter it, the interpreter will tell you about it only after executing the first 16 lines. On the other hand, the compiled language, it first goes the whole syntax and checks all kinds of things. So you can be reasonably sure that these low-level problems don't exist anymore in your code. You can still have problems like division by zero, or accessing an element in a list that's not within the range that we saw. So these kind of problems you still can have in a compiled language as well, but syntax errors you don't have once the program is compiled. Okay, so you make these checks earlier, not when you're actually running the program on the production machine of someone already. Okay, so that's the big issue. There's also the thing is that when you distribute an interpreted language, you need to ask the person who runs it to have the interpreter. So in a way, it's more difficult for them. But you only need to distribute that single source code you have. On the other hand, in compiled languages, you have to in compiled languages, you have to compile it to every different type of computer. So if you want to, you would like to distribute your program for Windows, Linux, and Mac, then you have to compile it 3 times. And for most languages, that means you need to have these 3 machines because you can only compile on their own machine. So for Mac, you need a Mac. And then also what you might remember, you have the 32-bit and 64-bit. So these are different ones. So now you need 6 different versions of your program. I mean, you still write 1 version, but you distribute 6 different versions. And then you have to take care of this. So it's more difficult for you to create all this. It's easier for the end user to just download and everything should work. Okay, so these are some of the differences. Usually, compiled languages are much stricter in the type system. So remember integers or floating point, or what is the size of the integer and the floating point. They're usually much more strict than the interpreted languages. And so I mentioned that the development mode in in the compile is edit, compile, run. So 3 phases. In the interpreter is edit, run. And even though it's like only 3 versus 2, it makes a huge difference in your productivity. I mean, it's 50% less, but it's actually way more, or 33% or whatever, depending which direction you say. But it's way more, it's way faster to do this with interpreted languages. So but I mean, not all of the languages are either this or that. There are some languages which are sort of in the middle. For example, there is Java. Java is sort of both. So in order to run Java, you take the Java source code, you compile it, and then you still need an interpreter on the target machine, which is, they don't call it interpreter, they call it the Java virtual machine, but primarily because it sounds better, okay? Then there is the C# or the Microsoft or the .NET languages of Microsoft, which is basically the same. You write source code, compile it, you receive something which is called the bytecode, and then you take it and run it on an interpreter. They don't call it interpreter because it's not a good name, and people think about it as something slow and whatever. And they don't call it virtual machine because Java already has it. So they call it common language runtime. But technology-wise, they are basically the same idea so in some way, both Java and C# sort of get the bad parts from both sides of compiled and interpreted, because you still have the three phases, and you also need the user to install something else in order to run your thing. Of course, it has they also have a lot of advantages. So where is Python? You probably ask after all these things. So let's take a look at an example, a couple of examples. So let's look at this code. If I try to run this code, okay, I will get this error message. So if I type in Python and the name of the file, I'll get this error message. It won't print out 2. It will just give me the error message, because this is a syntax error. It even says it's a syntax error. So Python first reads the whole code, checks the whole syntax, and only then starts executing. So one might think, oh, then it's a compiled language because it checks all the syntax. Okay, so let's go this one. Let's look at this one, this code. So here I assign 2 to the X, then print it, then print out Y. But I didn't have it yet. And then I assign value to Y. And then I just print out 42 just so you to see that if it works. Now if I run this, it will print out the number 2, and then I get an error which says name Y is not defined. So now it looks like it's the fact that the variable is not defined is a big no-no in all the compiled languages. They will catch you. They won't compile. So if Python did start running, then Python is not a compiled language, right? Like the others. So Python is sort of somewhere in the middle. Okay, it's both compiled and both interpreted. It has a compilation phase. So when you say Python something, it has what we call a compilation phase. When it checks syntax, it checks various things. It doesn't check all the syntax that C would check, or Java would check, or all these languages would check. It checks less things, which means it's also much faster to do this part. And then starts this interpretation level. Then it goes through all the commands again and actually does them. So you might have these relatively low-level issues that I used a variable that I didn't even create yet, which again, in a compiled language, this would be code before breakfast, right? So before anything, before you give it to anyone. In Python, it can run. Now, it has a lot of advantages in Python, actually, that Python works this way. I mean, one would say, so people who come from compiled languages, and this course is mostly for people who don't have programming background, but anyway, so people who come from compiled languages, or they usually also call these usually strongly typed languages, even though they are not, there's not different categories, but sort of they're connected usually. They would freak out on something like this. They think, oh, how can this happen? But this capability, which is now a problem in this example, but this is behind the scenes, it's a capability that gives a lot of power to Python, because it sort of says, it sort of delays decisions. It says, okay, I know that when you start out the program, you don't have this variable yet, but I sort of trust that by the time you need it, you will have it. And in this case, we didn't have it, but you know, that sort of it gives a lot of power to Python compared to other languages. Stuff that you might not notice yet, of course, but I think I sort of need to give an explanation why to do this. Also, Python, it doesn't. Sometimes, and I don't go into depth when, it creates these temporary files for itself, which is sort of like a compiled thing. It's very far from what the C or Java or languages would like this would do, but it's still good. So Python is sort of both. It has both a compiler and interpreter inside. Then you need both of them, but eventually, we as programmers on the day-to-day basis, we don't care. We just say, Python, this file, run it, and it does all these things behind the scene. Okay, so that's it about this one. And then another thing that I wanted to mention before we go on is, oh, I just mentioned it. I don't really go into, don't explain it deeply. I mentioned that actually you asked if I can replace internal variables or names of Python, and I said yes. That's actually a feature, but can be also a problem. And Python doesn't care or doesn't recognize them, but there are external tools. So for example, there is a tool called Flake 8 that can be used to notice all kinds of these issues, both the one that we just saw, so this one, not this one, sorry, I lost it, oh, here, below, this one. Okay, so when we use a variable before defining it, for example, or when you replace a function that, so you use a variable name, you use a name that's actually a built-in of Python, so Flake can notice this. We'll talk about it a little bit later. One thing that could actually say that if people use, for example, PyCharm, the PyCharm built-in has Flake 8. And it keeps compiling your code all the time. So a lot of these things that we notice later, PyCharm sort of gives you while you are editing. And that's one of the advantages of PyCharm. And maybe Atom does that the same, I don't know. And other editors might do it, but the higher level editors, I mean, the more IDE-like editors have these capabilities. Okay, any questions here? No, okay. So let's go through the next chapter, which we are going to talk a little bit about numbers, numbers in Python. So normally you would use decimal numbers, like with digits, but in some areas, and I wonder if you need them, probably not so much in biology, chemistry, but for example, even in graphics or electronics or whatever, they talk with hexadecimal numbers. So numbers on the base, in this base 16. So instead of you converting the numbers from base 16 to decimal base and then writing the decimal number in the code, instead of that, you can just actually write in the hexadecimal code, string. And then you assign to a variable inside, it's already just the number. So later on, at this point, when I'm printing it out, it already prints out 10, which is just this. So this is the decimal representation of the A. So, or A is the hexadecimal representation of 10, whichever you like it. So you say 0x and then the hexadecimal number, any digits you would like. Same way you could use octa numbers, so numbers that use 8 base, so digits between 0 and 7, which is even more rarely used, I think. Some areas use octal numbers. And then the binary numbers, which can again be useful some places, where each digit can be either 0 or 1, and you would use 0b, and then whatever comes after is the binary version. But once you did the assignment, inside these are all already decimals. Okay, so the only reason to use them is because you talk with your colleagues about something in hexa, or with the machine that you're talking to. Okay, or let's say, for example, colors. So when you say colors, they are usually represented with 3 numbers: red, green, and blue. So, and then they are usually represented with hexadecimal numbers. because that's sort of the convention. So there are areas where you can use them. And then you have just floating point number, nothing new here. You have the standard operations for numbers. So you have plus and division and whatever we had else, minus and all these others. But, and this is an interesting issue. So the division is also something that changed between Python 2 and Python 3. Python 2, when you divided two integers, you would get an integer as a result all the time. So if you divided 3 by 2, you would get only 1. It would round it down. This is how Python 2 behaved. And it has certain logic, okay? But the overwhelming desire of most Python programmers was that it just convert to floating point. So in Python 3, if you divide 3 by 2, you get 1.5. And you can use the same future construct or similar future construct that we had with the print function in order to convince a Python 2 to behave as Python 3. And on the other hand, if you use this double slash as the divider, as the operator, then it does the floor division. It's called floor division. So it behaves as if it was as the regular division was in Python 2. So 3 divided by 2, and this is what we have. 3 divided by 2 gives you 1. Okay. Again, it's very most likely you don't need this because usually you would want division to give you the as exactly as you would like, as it can. Historically, that was different, and that's why it's a little bit more explanation here. The 2 stars, we saw that already, that's the power of, so it's a on the power of b, so whatever a is 2 on the power of 3, that's probably 8, yes. Okay. Percentage style is the modulus operator. So you divide the 17 by 3, which is something times 3, so it's 18. 6 times 3, it's 18, and then 1 is the remainder. 15, sorry. Okay, so 5 times 3, you get 15, and then 2 remains. This I blame the video. Okay, so and then 2 remains. So 3 times 5 and plus 2, that's 17. So that this plus 2 is what remains, and that's what the modulus operator returns. Okay, and actually that's also something that I think it's rarely used, but it can be useful. Then very often or quite often you use constructs like this. So you have a variable and then you want to add something to it or reduce it by some number or multiply it by something. So you have this variable equals to the same variable and some operation. And this is too much typing for a regular Python programmer. So instead of that, you can write this shorter version of it. Okay, and it's especially, I mean, this example doesn't show exactly because the variable name is so short. But if the variable name is longer, then you would, and if you have several of these variable names that are a little bit similar, then it would be much clearer to write it this way than the other way. And you can use the same shortcutting with all the other operators as well. So not just with the plus, with the star, with the division, all of them. Some languages have this operation, a++ and a minus, that would increment a by 1 or decrement it by 1. Python doesn't have it. So in case someone watching this video who is used to this from some other language, no, in Python you don't have it. Instead of that, you would write this. Okay, that's basically the same. Or this, of course, reducing by 1. So basically the same. This was actually an optimization of C about 40 years ago. Okay, so and optimization to make the compiler work faster or something. So it's not really necessary. Okay, and here and there can cause problems. Yeah, so the future that I mentioned, so you can write here from future import print. Okay, that's the print function. Down, this is the division, sorry. Okay, so this is the print function that we already saw. And this is when I also can import from the future division. So I just import the division and then it starts acting as if it was already Python 3. Again, this is relevant only if you need to write Python 2 code, but you also would like to make sure that it works on Python 3, so you have this both behavior. So the same behavior gets to Python 2 as well. Okay, now something actually quite unrelated here, but still with numbers, and we need it for the exercise. So that's why I'm showing it right away. How do you get a random number? And computers are, it's difficult to get a really, really random number in computers, okay? Because the computers are too deterministic for that. And so the standard way to give a random number is not to give a random number, but to give what we call a pseudo random number. Have you heard about these pseudo random numbers? No, okay. So there is a link here to Wikipedia that explains. It's basically a mathematical function that gives you a series of numbers between 0 and 1, I mean floating point numbers, with lots of digits. And I always forget, I think it's, especially I don't remember now in English, it gives you a unified distribution, what is it called, that every number has the same likeliness to be picked. Anyway, so it gives you basically it gives you a series of numbers that looks like a random number from the naked eye. Okay, so if I call it random, and the random module of Python wraps this random generator of the computer. So
I remembered normal distribution.
Normal distribution, thank you. So when all the numbers can get the,
yeah.
Write it here because I always forget this. Have I mentioned that besides chemistry, I've also almost failed in statistics? So anyway, so import random would bring us the random module, and the random module has another function which is also called random. So it's now random, bad naming.
Okay. Not confusing at all.
Sorry?
Not confusing at all.
No, you're right. So this is random, and this is the function that returns a random number between 0 and 1. 0 is included, 1 can't be. So one is not included. So it's the range between 0 and 1. And if I run this, I get this number. Okay? And I just showing here that if you run the same thing again and again, you will get newer numbers, so other numbers. So if I switch here, and what is the name? It's Python rand. So it gives me 3 random numbers. I mean, they totally look random. Now, of course, if you knew one of them, you could actually calculate the next one yourself. So these are not really good for security or I don't know, lottery or stuff, because you actually can know what is the next number given the previous one. But it's quite good for many other applications where you don't really need where the predictability doesn't really matter. Okay. Then there are other tools. I don't think that I have a link there, that can actually generate much more real random numbers. You usually don't need them. They basically sort of gather the noise around your computer, like how much, what things you, entropy, right? And remember for chemistry, They gather entropy, and then using that entropy, they give you some random number. So basically, they are listening on the network, and everything that goes on the network, they just put into some bag, and then that's how they create or collect randomness from around the world or from around your computer. But that's not really that important now. The important is how do you use this one. So this random gives you just a random number between 0 and 1. And here, by the way, there is a link here to the documentation of this random module, because the random module can do more. But before we get that, actually, I wanted to show how the random function actually slightly show you a little bit more about how the random function works. So there is something we call a seed. You can tell the random function to start from a certain point. Okay, so if I say random.seed, let's say 37, the number actually doesn't really matter, but you see that, and then now run these things, then I get back these numbers. Now, if I go, okay, so this is the random seed. If I go back to my command line and run the rand again, so random rand by again, you can see the numbers that I ran, they are new. So every time I run, these are 3 new numbers. And what happens if I run this the random seed, I get the same numbers. These are 3 different numbers because I called random 3 times, one after the other. But if you look at the slide, these are exactly the same numbers. If I run this again, I'll get back the same 3 numbers because I told the pseudo random generator start from a given point. So basically what I just created is a repeatable randomness. So you get random numbers, but it's repeatable. It's exactly the same series every time. And this can be very useful if you would like to, if you create an experiment and you would like to make sure that you can run this exactly same experiment again with the same input pseudo-random numbers. It's used a lot for testing purposes when we are sort of using a random number, but we would like to make it repeatable. So we know exactly what to expect. Anyway, I just wanted to show you that this is how you fix your randomness. Okay. So how do you roll a die? I always forget how to say it, die, right? So how do you roll a die? Well, in most programming languages, you would write this line, something like this. So you would say, okay, the random or whatever the other programming language has generates a number between 0 and 1. I multiply it by 6. So now I have a number between 0 and 6. Still floating point, 0 can be, 6 can't be. So now it's a normal distribution between 0 and 6. I take the integer part of it, so now we can 6 integers, 0, 1, 2, 3, 4, 5. And the likeliness of each one of them is the same. And because it's a die, it's 1 to 6, so I add one to the whole thing. So now I got a number between 1 to 6, both can be, all the 6 numbers can be included. That works just like a die, okay? And fine, it's not very complex, but people keep messing up and there's no real use for this. It's much better to use another function of the random module, which is called randrange. You would tell it, okay, give me a number between 1 and 7, okay? And it will give you a number which can be either 1, 2, 3, 4, 5, or 6. Because Python wanted to be the same everywhere, and because the random doesn't include the upper limit, so every range you have in Python doesn't include the upper limit. So there are all kinds of places where you can give a range to Python. Here too. So it says 1 to 7, which means numbers 1 between 1 and 6, because 7 is not included. Okay? So this command would do exactly what I just wrote here, except that I have to do less thinking and less error. And the random module has all kinds of other functions. So just to be clear, the randrange behind the scene does exactly this. Okay, so it uses the random, or whatever base function. It's just a wrapper to make it easier for us to pick one random integer number in a range. Other tools. So random module has all kinds of other tools. For example, choice. You give it a string, for example, this string, and it will give you, pick one of the letters, one of the characters. So it does not need to be just letters. It can be anything. It will pick you one randomly. Okay. Or here we have a list. We haven't learned about list officially yet, but this is how a list of values looks like. And I can assign it to some variable. And I say random choice fruits, and it will give us one of them randomly with normal distribution. Okay. And wow, yes. So now let's make a mistake. Okay. So here is a couple of mistakes, I think. Right? There are coming a couple of mistakes because I like mistakes. I make them a lot. You have this code, import random, and then you say rnd equals to random. Okay, just what we thought, right? You see the bug? Okay, so let's see.
Not yet.
Not yet. So let's go for the next line. We print it out what the random returned, and it prints out this instead of giving us a number. Any idea?
Random. So we're invoking a function, right?
Close.
At that point.
Almost.
So we should have the parentheses.
Exactly. Exactly. So I forgot to put the parentheses here. It happens a lot. I see it all in the courses. It happens to experienced programmers as well, or at least it happens to me. Okay, so I don't speak in the name of others, but it happens to me a lot that I forgot to call the function. So I forgot to put the parentheses. So what random is actually the object that's the function. So the function itself is a thing. So what I assigned to R&D is not the return, not the result of the function working, but the function itself. So when I printed R&D, it said, yes, it's a built-in function, built-in method, it calls, but yeah, it's a built-in method called random, okay? And some other stuff, and this is the location in hexadecimal in the memory, and we don't care about this. The important part, I mean, that's the important part for beginners especially, that if you see this error message built-in method, not error message, this is not an error message actually. If you print out something and this is what you see, then you know that, oh, apparently I forgot to call the function. Okay, so that's sort of the clue, okay? Because this happens a lot. So, but now we actually could use the R&D as a function and put a parenthesis, and then it returns a random number. So we just basically gave a new name to the random. We didn't an additional name. So it's not that the other one disappeared. You could still use random, but now R&D is also mapped to the same thing. So it's an alias, let's say, to the same. It's a nickname, you can say.
But again, if you wrote R&D without the parentheses, it would give the same message, right?
Right, you would still get built-in method.
Right.
Okay, and if you would print out this one as it is, you would still get the same, exact same thing. Okay, so right. So the main purpose of this slide was to show you that if you get this kind of output somewhere, then you know that, oh, apparently I forgot to call something that was a function that was supposed to be called. Code, I mean, put the parentheses after it. That's what when I'm saying call a function, I mean, put the parentheses after the name. What you also said. Okay? Invoke the function. That's the other word for it. Okay, let's try another one. Another lovely thing that happened to me, happens to many people during courses. These things still happen to me and to other people with lots of experience, okay? It's a sort of a shortcoming of Python that this can be relatively easily happen. Whatever, that's what we live with it. So here is the code. Import random, looks okay. Print out, and then we say random. And this is what we get. So now I called it. Okay.
I didn't catch it still.
Okay. Do you remember how did you call it here?
Yeah. So we didn't put here. Here the problem was that we didn't put the parentheses.
What was the full name of the function?
Oh right, random.random.
Random.random. So
right. And
now we are just calling random, right?
Right. So you're calling the whole module.
The whole module, and this is what it says: TypeError module object is not callable.
Right.
Okay. So this can be also this can be also another common issue, especially with random, because it's so confusing of having two random. So and because of some other feature of Python, this can easily happen. And again, if this is an exception, but unlike the previous one, so this is a real error, but still both are not good. Again, if you see this kind of error, module object is not callable, then you know, oh, okay, by mistake I tried to call the module itself instead of the dot something that's the function or method. So the way to fix it is, well, write random, and then the parentheses. That's one of them. The other way is that we could actually import from the random module. From the random module, we import the random function. So now inside the random name actually refers to the function already. We don't have access now to the random choice of the random any of the others, because the only thing we have access to is the random function. Okay, so instead of bringing your whole family, it's only you came. Okay, that's sort of whatever. I don't have any better example here, but this is another way to importing stuff from modules, importing the individual functions, and then you don't have to write this random on one hand. On the other hand, you don't have access to any of the other functions. And you could import all of them one by one, but in this example, you only have one. Okay, one more. Yeah, you see, lots of errors can happen, and all of these are happening all the time. So, yeah, I think this is the one that is the big shortcoming of Python language. So here is the program. So this is a really simple program, nothing to do with random yet. So print hello world. This works, right? Well, I can tell you this works. And then I have this program in the same directory. Import random and then print random. This should also work, right? So now what I get here is this attribute error. Module random has no attribute random. Now you have to think outside of the box, literally, or see outside of the box.
So here,
I don't think that it's really likely that anyone would catch this who doesn't have already experience with it. Because I haven't explained the underlying method of something.
Right. No, I have no clue.
Right. So, yeah, it's obvious. It took, when I first tried it, when it first happened to me, okay, that was about I don't know, maybe 10 years ago. So I already had like 20 years experience in programming, and it took me 3 hours, I think, or whatever, a long time. Now I recognize this in a couple of minutes usually. Okay, but that's just to put again to put you in context of okay, stuff happens. So when I say import random, Python actually looks for a file called random.py. And by pure chance, I created a file in the same directory that I called random.py.
Right.
So Python loads this, looks for the random py, it will find my random.py and not the one that Python installed on my computer.
Right.
And then when I try to call the random module, the random function of this module, this module doesn't have a random function. So I get attribute to the module random has no attribute random. Okay?
Yeah, okay, that makes sense.
Right, right. So this is in the end, in some way, it's a shortcoming of Python that it doesn't have what we call namespaces properly. So it can easily happen that you have the same file name locally that is actually the name of a module. And sometimes I encounter this problem even in worst cases when I was importing a module, and that module, a standard module, and that was fine, but that module imported something, and that something was also in my directory. So I wouldn't even be able to see this. Oh, I'm importing random and I have a file named random. No, I imported something, and that something imported, I think, random, for example, doesn't matter. So think about it, I import something, and that thing imports random. And I also have the random py. In my code, I don't see anything that is imported that's problematic. And the error message is also about something totally different, not something that I import. So it can be a difficult to catch problem, okay? I'm showing you again, so hopefully when you encounter this problem, and everyone encounters this problem, you might remember to look at the idea or think about this idea. Right. Okay. We finished this chapter, so we have a couple of exercises. I think actually we have 2 exercises. So the first one is it's still called number guessing game. Okay. The official name of this game is one-dimensional space fight. Okay. So you have a spaceship in one-dimensional. And so because it's a one-dimensional dimension, it's in a distance from you, okay? So it's not your spacecraft, it's another spacecraft. And so the only thing that you know where it is a distance. And you need to shoot it down. So basically, you need to give or meet them because they're so friendly, whatever you think, okay, doesn't matter. So in the end, the game is that you guess what is the distance, and the program will tell you, okay, it was too short what you guessed, so the number is too small or too big, or whether you actually got the number, okay? And we didn't, so the whole game would be that the computer thinks about a number, a whole number, let's say in the range of 0 and 200 or 20, to make it easier to guess, and then you keep guessing. Now, we haven't learned that part of keep doing it. So in this exercise, you write the level 1 of the game. Later on, we'll continue. So the level 1 of the game, that the computer thinks about a number, you guess, and the computer tells you whether your guess was too small, too big, or the right number. Okay, and that's it. And then the other levels will come in the next chapters. So this is the first exercise. The second exercise is what now I call fruit salad. So yeah, I'm not even sure why do I have this exercise here. Oh, okay, sure. You can do this. Okay, hopefully. So you have this list, and again, we haven't really learned what lists are yet, but you already know how to access an element in a list, right? Because we had the sysrv. So it's the same, it's just called fruits. So create a fruit salad. So basically pick 3 fruits randomly, and that's your fruit salad. Okay, if you don't like the fruits, just replace them. So these are the two exercises, and now we go for the exercise breaks. You can do the exercise. Everyone who's watching the video can do the exercise at this point, and then come back to the time when we'll have the solution. Unless you still have some questions that for this.
Not for now.
Not for now. Okay, good. So thank you everyone for watching, and we are now heading to this break. So bye-bye.
See ya.